Hey everybody, this is Mr. Longo here, and this video is going to introduce you to fundamental trigonometric identities. But we're just going to call them trig identities. And we have some things that you should already be familiar with. By now you already know that cosecant is the reciprocal of sine, and secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. You also should know that tangent is sine divided by cosine. The ones that are possibly new to you are some of the Pythagorean identities. Now, you're already familiar with sine squared plus cosine squared is equal to 1, or at least you should be familiar with that. But the two new ones are what I'm always asked about. I'm always asked, Mr. Longo, how do I remember all three of these? And the answer to that question is don't memorize all three. Just memorize the first one and know how to get the other ones. What I mean by that is this. If you can memorize sine squared x plus cosine squared x is equal to 1, then you will easily be able to get the other two. Watch. The one below, you just have to divide everything by cosine squared x. If you divide every single one of these terms by cosine squared x, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. So that's how you get the other two formulas. I'm sure you've already figured out what I'm going to say about this one. You just divide all three terms by sine squared x. So again, there's no need to memorize all three of the Pythagorean identities. You can if you want, or you can just remember the first one and know how to get the other two. The next section of your notes are just tips or steps for proving identities. Now, we're not going to talk about all these. What I would actually recommend is you print this out and then we're going to use it. Okay? So just go to the website and click on the note sheet and print it out. And we're going to use it, okay? So we're going to get started. Now, all of this is just little baby steps working our way up to proving identities. So the first couple of videos are just going to be some little things working your way up to proving. And then once we get to proving, you might be doing like 8, 10-step questions where you're just going to have to keep on using correct mathematical terms and steps and stuff like that, and you will end up being able to prove identities. But to start, we're just going to do some simplifying. So the first two examples, we're going to simplify an expression to a single term without using division. Now, when we say single term, we don't mean that you can't write more than one thing. I mean, we could have multiplication if it can't simplify any further. So let's just simplify. If we look at the first one, we have tangent x times cosecant x over cosecant squared. The first thing that you should notice you're able to do is we have cosecant x on top and we have cosecant squared on the bottom. Now, whenever you're simplifying, you need to use correct math. What I mean by that is go back and think of this, x over x squared. We would simplify, we have 1x on top, 2 on the bottom, so that would simplify to 1 over x. Well, the same things can happen with trig functions. So we have 1 cosecant x on top and we have 2 on the bottom, so that can simplify to tangent x over cosecant x, because this one cancels one of the two that are on the bottom. Now we have to go to using no division. So we know that cosecant in the denominator would be sine in the numerator because it's just a reciprocal. So this is going to equal tangent x times sine x. And honestly, there's nothing else you can do. You are finished. If you change tangent to sine over cosine, you now have a denominator again. So it does not work. So you are done. Okay? That's what it means to simplify to a single term, meaning you simplify as far as you can without having division. Here's another one. Now this question, and I will tell you that there are going to be many questions that can be done in multiple ways. So there's a couple of different ways you can do this one. I'm going to do the first one that comes to my mind, and it's using Pythagorean identities. You have to use Pythagorean identities of some kind to do this problem. So one of the things, if you remember in the sheet above, cosecant squared is one of your Pythagorean identities. Cosecant squared can be simplified to 1 plus cotangent squared x. Okay, and then of course we still have our secant squared x, so we now have secant squared x plus 1 plus cotangent squared x. And now we have minus, and we've got something else to do, tangent squared x. Tangent squared x can be rewritten as secant squared x minus 1. And then, of course, we have the plus cotangent squared x. Okay, so I'll pause for a minute. You're asking me, how did I get tangent squared x is equal to secant squared x minus 1? Let's go all the way back up here. Tangent squared x plus 1 is equal to secant squared. So how? One of the things you can do with these is you can manipulate them. Tangent squared, we just subtract 1 from both sides. That's how we get secant squared x minus 1. So you have to also be able to be flexible with these. Sine squared could also equal 1 minus cosine squared x. Okay, so we'll be referring to this when needed, but each one has 3 technical steps. We could also say cosine squared is equal to 1 minus sine squared. So you have to be able to be flexible with the Pythagorean identities. Okay, and now from here we're just going to distribute our negative, and we are going to start combining like terms. So we have secant squared x plus 1 plus cotangent squared x minus secant squared x plus 1 minus cotangent squared x. And if we look, we have a lot of like terms. We have a secant squared x that cancels a negative secant squared x. We have a positive cotangent squared x, which cancels a negative cotangent squared x. And all we have left is a positive 1 and another positive 1. So that all simplifies to 2. Okay? So again, it's different, but it's math that you've done before. We've done combining like terms. We've done factoring. All of that stuff is coming back. We're just going to be doing it with trig functions. Okay, these next 2 examples are going to work with a different set of directions. These say to simplify in terms of sine and cosine only, which means in your final answer you are not allowed to use the word cosecant, secant, tangent, or cotangent. So the first thing we're going to do is follow the directions. We are going to remove cosecant x because we know that cosecant x is sine x as a reciprocal. So this is going to become 1 over sine squared x, because if we put cosecant in the denominator, we now have 2 sine x's, so sine x times sine x is sine squared x. Plus, we're going to do the same thing with secant. Secant x is 1 over cosine x. So if we bring a cosine to the bottom, we now have 2. So we have cosine squared x. Okay, so that's the first step. Next step, you have to remember how to add fractions. When you add fractions, you must have a common denominator. So the common denominator, or your least common denominator for this, is sine squared x cosine squared x. So this side's got the sine squared x, so this side needs the cosine squared x. This side's got the cosine, so this one needs a sine squared x. So we're going to add our 2 fractions, and we're going to have cosine squared x plus sine squared x all over sine squared x cosine squared x. Okay? So from there, you should be able to recognize that the top can be simplified. Cosine squared x plus sine squared x is the same as sine squared x plus cosine squared x, which is equal to 1 because it's a Pythagorean identity. And you are finished. I know you probably want to do more, but this one did not say you can't divide. This one says you can only do sine and cosine. So from there, there's really nowhere else to go. Now you could try manipulating some stuff. You could put, you could try to rewrite sine squared, but it's not going to do anything for you. You're done. Leave it alone. Okay, so this last one is going to be the most complicated one in the entire video. It's going to take us quite a few steps. So again, remember the rules. We are just going to simplify this to sine and cosine. So the first thing you have to deal with is this squared. Now you cannot do reciprocals. You can, but you will be asking for a really crazy ride. Do not just square both of those. Remember, this is like foiling. X plus 2 quantity squared is x plus 2 times x plus 2. So the first thing you have to do is secant y plus cosecant y times itself. You can never just distribute a squared when there's plus or minus. So you're going to FOIL that with itself, which is going to give you secant squared y plus 2 secant y cosecant y plus cosecant squared y. And all of that is being multiplied to cotangent y. So you still can't start doing reciprocals yet because you now have to distribute this to all three terms. So to do that, it's just distributing. So you're going to end up with cotangent y secant squared y plus 2 secant y cosecant y cotangent y plus cosecant squared y cotangent y. So that is now simplified to the point where we can start doing reciprocals because we're down to one big expression. We don't have any more squaring or any more multiplying to do. So now let's follow the directions. In order to do that, we're going to need a lot of fractions. We're going to need 3 fractions, to be honest, because we have 3 terms. So now let's start rewriting this in terms of sine and cosine only. So cotangent y is cosine y over sine y, because cotangent is cosine over sine. Secant squared y just goes down to the bottom as cosine squared y. Next fraction, we have 2 on top. Secant y becomes cosine y in the denominator. Cosecant y becomes sine y in the denominator. Cotangent y again becomes cosine y over sine y. And the last one, cosecant squared on top becomes sine squared y on the bottom. And one last time, cotangent y is cosine y over sine y. Yes, it's big, it's nasty, but we haven't done anything too crazy. Next, you need a common denominator to add all these together. This has 1 sine and 2 cosine. This has 1 cosine and 2 sine. This one has 3 sines, because sine squared times sine is sine cubed. So all of that has to simplify to a common denominator. Okay? So our next step is, let's just make this next step is just to help make things a little bit prettier. Okay? So we have cosine y over cosine squared y. We could take 1 off the top and 1 off the bottom. So this gets rewritten as 1 over sine y plus. We have a cosine y on top and a cosine y on the bottom. So this simplifies to 2 over sine squared y plus cosine y on top and sine cubed y on the bottom. Okay? So after all of that, I'm sorry, we also have a cosine y way back at the beginning. Almost forgot to write him. Now we can use a common denominator of sine cubed y cosine y. Now we can add our numerators after. This side needs 2 sine. This one needs a cosine and a sine. And this one just needs a cosine. So we have sine squared plus 2 cosine y sine y plus cosine squared y. Yes, I know, you're probably ready to be finished, but we're not finished yet. We still have to keep simplifying. Look what you have. You have a sine squared plus a cosine squared. That's a Pythagorean identity. Sine squared plus cosine squared is 1. So that can be simplified to 1 plus 2 cosine y sine y all over sine cubed y cosine y. So we've done a whole bunch, but that is as far as you can go. Now some of you are probably asking, when do I stop? Well, this is just baby steps getting to proving identities. Once you get to proving identities, you will know when to stop, because it's going to tell you specifically what you have to simplify it to. So you have to keep manipulating until you get to the one specific answer we are asking you for. But this one just said write it in terms of sine and cosine only and simplify as far as you can go. Before you say, can you cancel those cosines? Remember, the answer is no. You can't, because you have a plus sign on top. You can only simplify if it's multiplication or if you can take it out of both. So if that was cosine y plus 2 cosine y sine y, then yes, you could. But you can't. So you leave it alone. You're done. Okay? Now that video was pretty long because we had to tell you all about the rules and stuff like that. And you know what? The next couple videos in this unit are probably going to be pretty long as well. But that's okay. You guys are smart. You'll get through it. This is Longo and I'm out. See you, bye.